You've felt it. A glass slips from your hand, and in the fraction of a second before it shatters, the world seems to hang in the air. Each tiny rotation, the glint of light on the rim, the droplets of water arcing away in space, it all unfolds with impossible clarity. This isn't just a story we tell ourselves. It's a well-documented perceptual anomaly called tachycyclia, or the subjective slowing of time. It feels like you've been given a few extra moments, a pocket of stretched time to react. But what is actually happening inside your head? Deep within your temporal lobes sits a small almond-shaped structure called the amygdala. It's often called the brain's fear center, but that's too simple. Think of it as the brain's significance detector. When something unexpected and important happens, like a car swerving towards you, the amygdala doesn't just trigger fear. It essentially slams a big red button that tells the rest of your brain, "This is important, record everything now." This signal puts another nearby structure, the hippocampus, into overdrive. The hippocampus is responsible for forming new memories, and under the amygdala's urgent command, it begins writing data with incredible density and detail. Here is the first major twist. You don't actually experience the event in slow motion. The feeling of time dilation is a trick of memory. Neuroscientist David Eagleman proposes that during a critical event, your brain records a much richer, more detailed memory than it normally would. When your brain later accesses this memory, it's confronted with an enormous amount of information packed into a short time frame. It's like comparing a normal video filmed at 24 frames per second to a high-speed camera capturing 1,000 frames per second. Both recorded for 1 second, but the high-speed footage contains vastly more information. Your brain's logic concludes that for so much to have happened, it must have taken longer than it actually did. It's a retrospective illusion. But is it all just a memory trick? Perhaps not entirely. Your eyes don't see a continuous movie of the world. They take snapshots, and your brain stitches them together. The speed at which you can process these snapshots is called the critical flicker fusion frequency. It's the point where a flashing light starts to look like a solid, continuous beam. For humans, it's around 60 Hz. For a housefly, it's closer to 250 Hz. This is why it's so hard to swat a fly. To them, your approaching hand looks like it's moving in slow motion. Some research suggests that in high adrenaline situations, a human's flicker fusion rate can temporarily increase. You might literally be seeing more frames of reality per second. To understand this, you need to know that you have a clock inside your head. Not a single clock, but a complex timing system coordinated by an area called the striatum. The tick rate of this internal clock is heavily influenced by the neurochemical dopamine. When you are bored or depressed, dopamine levels can drop. Your internal clock slows down, and time seems to drag. But during a frightening event, your brain gets a massive surge of neurochemicals, including dopamine. This surge dramatically speeds up the ticking of your internal clock. And when your internal clock is ticking incredibly fast, the outside world, which is still moving at its normal pace, seems to be passing by in slow motion by comparison. So it's not one single phenomenon. It's a cascade, an elegant survival system. The emergency happens and the amygdala sounds the alarm. This does two things at once. First, it floods the brain with chemicals that may increase your perceptual frame rate, letting you take in more information about the world in real time. Second, it commands the hippocampus to create a hyper-detailed, high-fidelity memory of everything that's happening. The result is a dual effect: a real-time perceptual enhancement followed by a powerful retrospective memory illusion. This gives you the best of both worlds, more perceived time to make a decision, and an incredibly rich memory to learn from if you survive. Ultimately, this reveals something profound about our experience of reality. We tend to think of time as a constant, objective river flowing at the same rate for everyone. But your brain doesn't just passively observe time, it actively constructs your perception of it. Time isn't just a ruler to measure events, it's a flexible, elastic resource that your brain can stretch and compress. It's a tool warped in the service of one fundamental goal: keeping you alive. Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.